complex roots does the function have? What are all the roots? So first of all, complex roots just means what's the highest degree. So how many roots does this have? 3. So there's 3 solutions. Now that doesn't mean there's 3 real solutions necessarily. It just depends on the problem. So it says what are all the roots? So we know there are 3 complex roots. We're going to go through and find all the roots. Now what's hard is there's like 4 different ways to do this problem. And I sat and debated which way I would do this one. And I think I'll do it this way. So first of all, let me just tell you what you could do. You could graph it on your graphing calculator. Let's all do that real quick. Go y equals, and then type in x cubed plus 8. Now you see that cube function, and it looks like this, crossing and going up. So it's crossing at -2, right? Everybody, x equals -2. Does everybody see that? So we have that solution, x is equal to -2. So there's one of our solutions. Well, we know we have 2 other solutions, but since it's not crossing the x-axis again at all, the other 2 solutions must be imaginary. Does everybody understand that? So there's 2 different ways we could go about solving this. The first way I'm going to do it is, can't we factor a cube? 2 perfect cubes. Isn't this x cubed, guys? X, and then this is 2, 2, 2. 2 times 2 times 2, right, everybody? So this is a sum of 2 perfect cubes. So we could factor this. We know it factors to be x plus 2. Doesn't the sign stay the same? We've learned this, right? And then you do the front with the front. The front's x, so x squared. The front with the back, that's 2x. We don't put in our signs till last. Front with the front with the back with the back. 2 times 2 is 4. So our sign was positive, so this is opposite, right? And this is always positive. Now, look, guys, it's making sense. Do you see where the x equals -2 came from? Isn't that a linear factor? Don't we say linear factors equal to 0? So we know x is equal to -2 is one of our solutions, which we were able to do by graphing. Now we could have done synthetic division using this and got here, but you would have had to, you know what I'm talking about, right, everybody? You would have put in -2. We would have put in, so there's 2 different ways to get here. We would have put in our coefficients. So 1, are we missing x squared? Guys?
Yes.
So we put in a 0, aren't we missing x?
Yes.
So we put in a 0, and then we put in an 8. So then we go through and do synthetic division. You know what I'm talking about, right? We would get the leftovers, and it would have come out to be this. Okay, so now we can solve this. I always try to see if it solves by factoring, but it doesn't. What multiplies to be 4 and adds up to be -2, nothing. Does everybody understand that it does not factor? That doesn't mean we can't solve it. We can always solve the quadratic by the quadratic formula, which is what you have to do if you have 2 imaginary solutions, which we know is true. So we would then find the other 2 solutions by doing x equals the opposite of b, so +2 plus or minus the square root of b squared. So I'm going to type this in, -2 squared minus 4 times a, which is 1, times c, which is 4. So underneath the square root was -12. All over 2 times 1. Is everybody comfortable? Some of you kind of suck at the quadratic formula and you should be able to do it easy. So we go off to the side and say I'm going to break down -12, right? 4 times, guys, are you paying attention? And then 2 times 2, right?
Yes.
2i square root of 3. So we have x is equal to 2 plus or minus. We pulled out a 2, we pulled out an I. 2i square roots of 3 all over 2. Now you look, do all 3 things divide by 2?
Yes.
Or by something in common? Yes, the 2. This became a 1. Don't just cross them out and say they're gone. They become 1. 1, 1. So our final answer will be x is equal to 1 plus or minus 1i is just I square roots of 3. And then divided by 1 is just itself, right? So this would be our final answer. There's all 3 solutions. Questions? Okay, next problem. Okay, simplify. Write it down. Okay, guys, this is a fraction subtract a fraction. To be able to do this, you have to have a common denominator. Do you all understand that? Do you have to have a common denominator to multiply fractions? No, right? You multiply straight across, right? But if you add or subtract a fraction, you have to have a common denominator. Do we have a common denominator? Yes. So can't we say that it's going to be all this stuff, subtract all this stuff? Now, this is subtraction. This is a red flag problem. Be careful. With subtraction, are we subtracting all of that? Not just the front thing, right? So I'm going to say I got to put that in parentheses. So we know on top we're going to have 2x minus 3 minus 5x plus 3. You forget the minus sign, you're missing an easy problem just from one little error. And that's all over 3x. Now we can put it together since they have the common denominator, right? That's our goal. So we're going to distribute our negative through. So that'll be negative 5x, right? Minus 3. So technically cross line, change the sign, change the sign. So then 2x plus negative 5x. Negative 3x's, negative 3 plus negative 3. Minus 6 all over 3x. Now that technically is our answer, but it's not the most simplified answer. Because isn't there something on top we can factor out? We'll factor out a negative 3 of the top. So we factor out a negative 3. Left is x plus 2. Am I right?
Yes.
Yeah? And then we have all over 3 times x. Now remember, if it's connected with a plus sign, you cannot divide it out unless there's that exact factor. But if it's connected with multiplication, you can divide it out. So can we take this negative 3 and divide this 3? Yeah, right? Isn't all those connected by multiplication to the other things? Okay, so that becomes a 1, that becomes a 1. So our final answer is negative x plus 2 all over x. Right? 1 times x is just x. This would be the final answer. Questions? Okay, next one. So it says simplify. So once again, we have a fraction added to a fraction. If you are adding or subtracting fractions, no matter what the fractions are, you have to have a common denominator to put them together. So usually you'll want to do the least common denominator so that you don't have to simplify as much in the end. So let's look here. We have a 3 and an x, right? Definitely I'm going to figure out my LCD, the least common denominator. We have a 3 and an x. And this one we have an x. Have we already accounted for x? Yes, right? So our least common denominator is 3x. Does everybody understand that?
Yes.
So this one's good, but this one needs to be manipulated. We're going to multiply by a fancy one of our choice because 1 doesn't change anything. So we're going to multiply by 3 over 3, right? So you have to multiply the top and bottom by 3. That's a fancy 1, so that's why it doesn't change it. So we have 2 over 3x plus 3a over 3x. Now do we have a common denominator?
Yep.
So now we can combine our top. We have 2 plus 3a all over 3x, right? Do you add the bottom? 3x plus 3x is 6x? No. Okay, good. So we're done. There's nothing more we can do here, right? Can you say 3 over 3? No, it's connected with a plus sign, right? This is an exact factor. Do we all understand that you can't do 3 divided by 3 right here? Okay. Questions? What if this would have been my answer? 2 plus 3a all over 2. Can I say, oh, yeah, 2 over 2 is 1? No, right? That 2 is connected with a plus sign. We all understand that, right? Because you didn't, like when we first learned it. We're good now, though.
Outside like parentheses.
Right, it has to be connected with multiplication, which outside the parentheses, that multiplied to that. Yeah, good. Hey, next one. Go, write it down. Okay, so it says simplify. So once again, we're adding and subtracting fractions. We need a common denominator. A lot of you think you can do really weird things with these that you are not allowed to do. So pay very close attention. The only way to manipulate a problem here, because it's not an equation. Does everybody know an equation has an equal sign, right? This is not an equation, so you can't add things to change anything on here. You cannot do that or you change the problem. The only way of fixing something is multiplication, so keep that in mind. So first of all, we have to have a common denominator. Now look, a lot of people tend to say x plus 1 and x minus 1. So I can make them the same by subtracting a 1 and adding a 1 here. Did you just hear what I said though? You cannot add things to non-equations. Do you all understand that? You can't just do that to the bottom. You get what I'm saying? You can't add 1 to the top and bottom. You can't add things. You get that, right? So let's figure out our least common denominator. Now remember, exact factors and factors are connected with plus signs, so x plus 1 is an exact factor. You all understand that? So in our least common denominator, we're going to have an x plus 1. Let's go on to x minus 1. We've already accounted for nothing, right? Isn't x minus 1 completely different than x plus 1? So we have x minus 1 in our denominator. And then x. Can we call these x's the same as that x? No, right? So we also have an x. So our least common denominator is x times x minus 1 times x plus 1. So we're going to have to manipulate this accordingly. All the denominators need to look like this. So looking here, we have x plus 1. What do we need? X and x minus 1. So we're going to multiply that x and x minus 1 to the top and bottom. So everybody good? Let's look right here. What do we need to multiply by? An x and an x plus 1, right? You guys all see how we have an x minus 1. We need an x and an x plus 1. So x over x times x plus 1. Sorry. And then in this one, we need to multiply by x minus 1 times x plus 1. Is everybody good? Now our denominators are going to be the same. We've got to multiply this very carefully here. So on top, we have 3 and x being multiplied to both of those, right? So we're really doing 3x times x minus 1, right? Everybody, are we all good?
Yes.
So we have 3x squared minus 3x, and then it's all over the common denominator. I'm not going to write the common denominator. It's that, right? For a second, I'm not going to write it. Is everybody comfortable with that? Yeah? Okay, let's go on right here. Now we have to be careful. It's subtraction. So we have 2x times x plus 1. So really we're multiplying 2x squared times x plus 1, right? 2x times x is x squared. And then isn't it really negative 2x squared? So don't we distribute that negative through with that 2x squared? So negative 2x squared times x is negative 2x cubed. Negative 2x times 1 is negative 2x squared. All over the common denominator. I'm going to write it in the end. And then we're multiplying this 4 with all this stuff. And it's positive, so we don't have to worry about negatives. I'm going to multiply those together first. We'll multiply an x times x is x squared. X times 1 is plus 1x. Minus 1x. And then negative 1 times 1 is minus 1. So are we multiplying 4 to x squared minus 1? Combining like terms, right? So then we're going to be adding 4x squared minus 4. So that's our top. Let's combine like terms. We're almost done. So let's start with our highest degree, which is negative 2x cubed, yeah? And then negative 2x squared plus 3x squared plus 4x squared. How many x squareds? Yep, plus 5x squared. And then negative 3x minus 4, and it's all over the common denominator of x times x plus 1 times x minus 1. Questions? Then you would simplify it if possible, but this one doesn't simplify. Questions? Okay. Simplify. So we have 2 over abc squared minus a plus 3 over a squared bc's. So really the trickiest part is not messing up on figuring out what the least common denominator is. So we've got to make sure we're really careful. So I'm going to let you get that down and then we'll go through it. So we have an A, B, and 2 C's, right, guys? In this one. So we definitely, starting out, need an A, a B, and 2 C's. C squared C. I'm writing it like this for a point. Now in this one we have 2 A's, right? So don't we need 2 A's? So we'll need another A. Are we all comfortable with that? Then we have a B. We've already accounted for B. That's good. We have 2 C's. We've already accounted for C, right? 1 C. So our common denominator is A squared B C squared. Does everybody understand that? Yeah? Okay, so right here, we need A squared B C squared. So don't we need to multiply by A? Right? So multiply A over A. You gotta do it to the top and bottom. Over here we have A squared B. We need C squared, so we'll multiply by C over C. Dang it. Why did I do this? don't know why it does that sometimes. So keep going. You have 2a. You have 2a over a squared bc squared. Keep going. So you have 2a over a squared bc squared minus, we're multiplying by c over c, so we have, and let's multiply, that negative is like, we've got to be careful, right? So let's multiply by negative c to both of them. Is everybody paying attention so I don't confuse anybody? So negative a times c is negative ac, right? Let's careful, don't we need to distribute the negative? Negative 3 times c is negative 3c's, right? So now we distributed the negatives through, and that's over a squared bc squared. So now they're all good. Now we just combine like terms, which on the top there's no like terms. So we have 2a minus ac minus 3c all over a squared bc squared. Now let's think about it. Can we start dividing out a's and stuff? Connected by a... So look on top. Aren't these all connected with a minus sign? Now was there anything in common in all three terms we could factor out? No, right? So can we divide out anything unless it's exactly that? No, right? We can't divide out pieces. Do you guys all understand that? Okay, so this would be our final answer. So you might be saying, well, 2 and a are multipliable. Yeah, but it's connected to minus ac with a subtraction sign. Does that make sense, everybody? Okay. All right. We're almost there. Solve. So we're asked to solve. So now we're dealing with fractions. We're solving rational, which means fractional expressions. So now we're solving. To solve, you have to have a common denominator. There's many different ways to solve, guys. That's why math is crazy sometimes, is because you can solve many different ways. But one rule is you do have to have a common denominator. But so we can go about this two different ways. The easiest way in my book is to say I have a fraction equal to a fraction. Can I just cross multiply? I'm not going to get a common denominator. I'm going to cross multiply this one. Do you all understand what I'm saying here and why this will work? So I'm going to multiply both sides by x squared minus 25. X squared minus 25. You have to do it to both sides technically, right? Guys?
Yes.
So then over here, x squared minus 25 divides by x squared minus 25 and becomes 1. So I'm going to multiply both sides by x minus 5, but it divides out, so x minus 5, x minus 5. I'm going to put it in parentheses, and then this divides out and becomes a 1, right? So on top, we have x squared minus 25 times by 1 is equal to, and does everybody see how I got rid of our fractions, which is way better?
Yeah.
Mason, you're the best baker. And then we have x times x minus 5, which is x squared minus 5x. Okay, so then this times 1 just itself. So we have x squared minus 25 is equal to x squared minus 5x. And now we just solve for x algebraically, right?
Yes.
Right now it's quadratic, so let's combine our x squared. So to bring this x squared over here, won't we subtract x squared?
Yes.
So we have negative 25 is equal to, that became a 0. Ooh, nice, that became a 0, right? So we're not dealing with a quadratic. Phew, otherwise we'd have to solve using quadratic formula, right? So we have is equal to negative 5x. Now it's not quadratic, lucky us, but if it was, we would be able to continue solving. So then we would divide both sides by, so x is equal to 5. Then you can check your answers by plugging in a 5 back into the original problem, and if it comes out to be the same, you're good. So, questions? Okay. This one I want to do because you have to get a common denominator. There is no cross multiplying with this one because we have multiple terms. Okay, so we have this. We're solving it. Now it has an equal sign, so we want to get a common denominator. So, first of all, our least common denominator. Least common denominator, we have a b plus 1. We have a b minus 1, right? Now to note this, we need it in factor form. Do you all understand that? We would not say b squared minus 1. Let's factor that, and then we can look at the factors. So we're looking for what multiplies to be negative 1 and adds up to be 0. 1 times 1, right? Negative 1 times 1, yeah? Doesn't that quick factor to be b minus 1 times b plus 1? Yes. So this bottom is really that. So aren't we good?
Yes.
Okay, awesome. So now, let's fix what we need to fix. This has a b plus 1, it needs b minus 1. So we multiply by b minus 1 over b minus 1. Anytime you have two things, you'll use parentheses. Did you all hear that? Because you missed it on the mid. Okay, so then we have a b. So now we'll have, okay, we're good there. B minus 1, we need b plus 1. So I'm going to put it in parentheses, b plus 1. And then this one's good, right? This has a b minus 1, b plus 1. Isn't this good? Okay. So now, guys, now that we have a common denominator, we can solve without using it. That's only for solving. You guys understand that, right? Simplifying, you need it there. Okay, so now we can solve, because we have a common denominator, we can solve. So we have 1 times b, 1 times negative 1. So that's b minus 1, right? Plus, we don't have to be careful, it's not subtraction, which is good. So we have 1 times b plus 1. So we have b plus 1. 1 times b is b. 1 times 1 is 1. And that's equal to 2. Now it's just algebra, solving for b. b plus b is 2b's, right?
Yes.
2b's plus 0 equals 2. So b is equal to 1. You can check your answer by plugging it back in for b and then calculating it. So that's 1/2 over 1/2 plus, and then this better be, oh, it's undefined. Wait, let's see. Let me think. So I'm checking my answer now. So 1 over 1 plus 1, right? Plus 1 over 1 minus 1. Okay, this is a good point. Is everybody paying attention? I need to check my answers. And then we have is equal to, I gotta erase this, so I want to keep it in line. Is equal to 2 over, and then it's 1 squared minus 1. Let's see if this is true, otherwise we need to throw out the solution. Guys, are you listening? So we have 1/2 plus 1 over 0 is equal to 2 over 0. Can we divide by 0? No, all of a sudden this became undefined, right? So was b equal to 1 a solution?
No.
No, we didn't do it wrong, but we would throw that answer out. So b equals 1, nope. So we would say no solution.
So,
Was there any other solutions for this one? No, we solved, right? Didn't we do our algebra right? The only solution we found was 1, but was that a true solution? It's called an extraneous solution, right? So you throw that solution out, which let's make sense of it. I mean, that does make sense why b should not be equal to 1, because we'll have to make our bottom 0. We plug in 1, then 1 minus 1 be 0. So that's why we threw that answer out. Is everybody good at that? So check your answers, is what I'm trying to get at. Okay, that's the last one I'll do. You're doing these pages. Now guys, we're completely not doing page 32. You can cross it out. We're completely not doing page 34. Cross it out. We have not had time to learn that stuff, unfortunately.
yeah.
So cross those out and begin working and checking off your packet.